All right, I want to show you one more of these. I remember what we call them. It's a chart problem. So I want to do one more of these chart problems and then have an interesting bonus for you. It uses the word second derivative. So there's going to be a bonus that uses a second derivative. But look at letter F. Still have your book there? G of x plus f of x to the negative 2. Are you getting the idea that these functions, even though they're just written generically with g's and f's, still have insides and outsides? Okay, this problem is a perfect example. Negative 2 is on the outside. It's a chain rule problem. So when I do the derivative, yes, we're going to use the chain rule. And just to kind of help you see, part of the chain rule is right there. It's the derivative of the outside. So like you actually do the derivative with the actual number negative 2. Okay, I actually change the exponent. But to leave the inside alone is just to recopy this f or this g and f. Now when we do the derivative of the inside, okay, when you multiply by the derivative of the inside, you're going to multiply by the derivative of g, which is g prime, and the derivative of f, which is f prime. Okay, so sometimes people are like, so that's it? That's all I have to do? Well, yeah, but when you write f prime and g prime, you're actually doing the derivative. Okay, well, you're going to plug in. Sometimes people are like, what's this x equals 1, x equals 0? There has to be a place where you're doing the derivative. The place is an x value. So we basically just use the second row of the chart. I encourage you to plug them in. You can look at the chart. I mean, I'll show you up here. This way you know that you're looking at it the right way. Those two numbers should find themselves on the inside. That would be G and F. And then negative 8/3 and negative 1/3 will find themselves on the outside. Maybe you're tempted to use a calculator, but the problem is kind of designed that you don't need to. I know there's a negative exponent, but it's just negative 1 to that exponent. Now, if you have negative 1 to an odd power, it's still going to come out to be negative. Over here, we have some common denominators, so you can actually add, and you can do the problem without a calculator. It's just going to come out to be positive 2 times negative 3, which is negative 6. In the assignment, you guys will find yourselves doing number 56. It's the one right before it. So you have some, I picked out these three to kind of give you a flavor. All right, again, be careful. I know where we're at. We're at a little bit of a tipping point. I'm talking about calculus, okay? And that is, are you going to keep working on this, or are you going to maybe rely on the solution manual too much? Just be careful. Kids that rely on the solution manual too much kind of comes back to bite them. But as you work through the assignment, kind of like I told you at the beginning of the year, that's where you're learning. Okay, so don't copy. It's honestly a waste of time. You have to kind of make that decision, okay? When you guys go off to school, you'll be making the same decisions, okay? I want you to become the best you can be. And you kind of have to take responsibility for that. Okay, now what I like to do with this problem is offer it to you as bonus, but I'm not going to give you like a piece of paper because I don't want you to hand it in. It's actually something I want you to have in your notebook. So what we say is just about 20 minutes. That's going to be like quarter after. At quarter after, I'm going to take a look at what you came up with, and we can learn a little bit through this, like basically if you got it right or maybe you made a mistake, we'll take a look at the answer. So you're trying to do the second derivative of 9 tangent of x over 3. Now, I don't care if you talk about it. You guys can learn from each other. So at some point, you might decide that you want to talk to someone. The one thing that I'm going to say to you, because I really hate to see this mess you up, x over 3. X over 3. That's the same as 1/3 x, right? 1/3 x. So you really need to be careful as you think of 1/3 as part of the inside. Okay, that hopefully will get you onto the right start with the derivative. So you're doing the second derivative